Good morning, guys. Today we're going to take a look at page 15 of the Unit 4 Classwork packet. Today's really just a review of a couple key concepts from Algebra 1 that you're going to be using quite frequently in this chapter to write the equations of parallel and perpendicular lines. The first of those concepts is slope. Now, slope, as you'll recall, is a rate of change. When we're talking about a line, we talk about the slope as being the rise over the run. And we know that slope can be positive, negative, 0, or undefined. If we have a line that rises from left to right, as in when I put my finger on it and I go to the right, it's going up, we would say it has a positive slope. By contrast, a line that when I put my finger on it and as I move, it falls would have a negative slope. A line that's flat, and by flat we would say horizontal, has 0 slope because I'm never rising and I'm never falling. I am simply moving, in this case, to the right. Last but not least, a vertical line has what's called undefined slope. And the reason it's undefined, if you'll recall, is that because the x never changes, if we use the change in y over change in x formula, well, I'm not really allowed to divide by 0, right? So this right here, the vertical line, would have an undefined slope. Now, if we want to find slope, we have a couple different ways we can do it. And the method we're going to choose depends on what we're given. So very briefly, because I know that this is something you guys have already done before, right? At least, let's hope so. Let's take a look at number 1, okay? When we're given 2 points on a graph and we're asked to find the slope, okay? All right, let me just make sure I'm drawing this correctly. So give me a moment here. There's that -2, -3. And then they give me 3, 1. Okay. All right, so method number 1, what's the formula we would use? Well, to find the slope of a line given a graph, a lot of times we like to use this formula right here. Rise over run, right? So in this particular case, all I would have to do is kind of draw a triangle. Some of you guys remember briefly from pre-algebra, one of your teachers may have said something about slope using similar triangles, okay? So if so, congratulations, you know far more than you need to for this. But what we want to do is make sure we know how many we rise and how many we run. So counting, I rise 1, 2, 3, 4. Let me write that down. And I run, let's see, 1, 2, 3, 4, 5. So in this particular case, what I would say is that the rise over run equals 4/5. So we can summarize that as the slope is 4/5. That would be the same if you're taking a brief look with me at example number 2. The only difference is because it's falling, I would have a negative slope instead of a positive slope. For example 3, because it's a vertical line, it would just be undefined slope. And for example 4, because it's a horizontal line, it would have 0 slope. Now let's take a brief look at when we'd have to use the other method, which is the slope formula. The slope formula is something that you guys have seen before in Algebra 1. I would say it's pretty useful. A lot of people don't like it, mostly because they kind of mess up their integers sometimes. But this is the slope formula right here. M equals y2 minus y1 over x2 minus x1. For those of you guys who one day take a physics class, they may represent it slightly differently. They may represent it as delta y over delta x, where delta just means the change. You don't need to know that for my class, but just looking forward, this will come back in applications in other subjects such as physics, okay? Now, the way that we would apply this formula is by simply plugging in the points. And for that, let's take a look at example number 5. Okay? Example number 5 gives me 2 points. So they give me -2, 5, and they give me 6, -1. Now, this is a personal preference, but one thing I always like to do is I like to label. The reason I like to label is that it helps me keep my work straight and prevents me from making silly mistakes later on that could cost me untold numbers of points. So here's what I'm going to do. I'm going to call this x1, y1. And what do you think I should call this? You guessed it, x2, y2. Now, could I have reversed this and actually called it, x2, y2 and x1, y1? Sure, doesn't matter to me as long as you're consistent, right? So now, let's plug in. So we need y2 minus y1, so that means -1 minus 5. Let me write that down, -1 minus 5. Over x2 minus x1, so that would be 6 minus a -2. Again, take a look at that, 6 minus the -2. When I go through and simplify this, I lost 1, I lost 5 more, that means in total I lost 6. And in the denominator, minus a minus is a plus. Going back to our 6th grade reducing fractions by the GCF, was the GCF is 6 and 8? The GCF is 2, so I divide both the numerator and denominator by 2, and I get -3/4 is my slope, okay? Now, on the end of course exam, how might you have to do this? They're not going to give you a problem where it says find the slope. Instead, these questions are going to be embedded within a question about parallel or perpendicular lines, okay? So this is not going to be the actual question, but you need to remember how to calculate slope in order to be able to answer the questions that they ask, okay?